Okay, Matt Roscoe here at the University of Montana in our course Math 234, Higher Math for K-8 Teachers. A quick video to explain the nature of the project for this third part of our course, which is on algebra. So if I go to the algebra section of our Moodle page, I can see that there is now a Project 3 resource folder. I will say that before you go about, I guess, listening to this video, it might make better sense for you to go ahead and watch the motivating video for the project, which is this link right here, the URL to Project 3 Soda Water video. This will take you off site and to my YouTube channel, and you'll watch this video there. I won't watch it right now. I'll let you do that on your own. But once you've watched the video, then let's take a look and see what the project is about. So you'll see in the Project 3 resource folder a whole bunch of documents. And so I guess what I want to make sure you understand is that each of these documents has something to do with the project, but the project statement is the 234 Project 3 linear modeling. Instead of watching it download, I've already got it download, and we'll go ahead and take a look at it now. Here's what the project statement looks like. So the background information is that the use of variables, algebra, and functions are essential to the mathematical process we call modeling. So the Common Core state standards for math practices and content define modeling as the process of choosing and using appropriate mathematics and statistics to analyze empirical situations to understand them better and improve decisions. So one thing you should make sure you're understanding, empirical is somewhat of a fancy word for real world. So we're talking about real world situations, ones that we can find in the real world. So in particular on page 72 of the Common Core, where the modeling standard for high school is elaborated, there are this sort of 6 important processes that are features of the modeling settings. That is, the identification of variables in the situation and selecting those that represent the essential features of the situation, and then a formulation of a model by creating and selecting geometric, graphical, tabular, algebraic, or statistical representations that describe relationships between variables. The third, I guess, important process is analyzing relationships to draw conclusions. So once you have these models built, how can you analyze them to make some conclusions? And then interpreting the results of the mathematics or the conclusions that resulted from the analysis in terms of the original situation. So taking the math solution back into the real world and asking, what does it tell us about the real world? And then some sort of attempt at validation to try to make sense of the conclusion by comparing it with the situation to try to decide whether it's really a valid solution. And then finally a report on the conclusions. So again, this is on page 72 of the Common Core, where you'll also find this little diagram. I'm not a big fan of the diagram, but the idea is that it's supposed to be a process diagram from problem to report. So you have some problem in the real world, you formulate a model, you do some computations and some analysis, and then you try to interpret the results of that models and its analysis. And then you ask yourself, does the model make sense? Is it valid? If it's not valid, then you go back to the formulation process and repeat the cycle. If it is valid, then go ahead and report the results of your modeling activity. So for the project, what I want you to do in terms of the requirements, I'm asking you to display your knowledge of the standard 12 linear functions, which is on the following pages, actually not on the reverse, but on page 3 here. By engaging in a linear modeling activity. So our Moodle site is a link to a video called Soda Water. Watch the video at least 2 times and then reflect on the content. What mathematical questions does the video prompt you to ask? What are the important variables in the situation? How can you write equations to represent these variables? What conclusions can you draw? And do your conclusions make sense? Why? And can you write up a short report of your findings? So what I think you should probably do to display your knowledge of modeling, linear modeling, is to write up a concise, that means short, it doesn't need to be long, and well-worded presentation of your investigation using the 6 headings. So I'll be looking for the 6 headings in your write-up for the project. Identification. So the first thing I want you to do is define the question you seek to answer, and then define the variables that are essential to answering the question. Be sure to include the units of measurement for each variable. From there, go ahead and formulate. So in the formulation section, you should create a mathematical model of the situation by creating and selecting geometric, graphical, tabular, algebraic, or statistical representations that describe relationships between the variables. So here I want to make sure that you include mathematical representations of linear functions. So the situation you've been giving is one in which linear functions play an important role. I would also say that probably graphical, tabular, and algebraic are the three that I would most likely see you produce here. I'm not, I guess I'm not expecting anybody to use a geometric representation or a statistical representation. So in terms of analysis, use the model you've created to mathematically draw conclusions. So for example, does a solution exist? Where is it found? What equation would you solve to find it? And what can you say about before and after the solution point? Um, and then go ahead and move on once you have the analysis done to interpreting the solution. Here you should provide a brief verbal description of your analysis and connect the mathematical analysis to the situation to provide a solution in the context of the problem. So for example, if x comma y 3.5 comma 7.35 is a solution, what does that solution mean in the context of the modeling setting and the real world setting? The last thing is, well, second to last thing is to validate, so provide a verbal reflection about the appropriateness of the solution. So ask whether the solution makes sense or if it could be improved upon. If it needs improvement, go ahead and return and improve it. If you can provide evidence that you have a reasonable solution, then proceed to the last stage. This is probably going to be the most, I guess, sort of wonky part of the project. One way to validate is to compare your solution with somebody else who's in the doing the project. You know, ask them, you know, what kind of solution are you getting? And if those solutions seem to be somewhat similar, then I think that that's one way to say, yeah, I must be in the ballpark. Another thing is just to ask yourself, you know, why does your solution make sense? Can you provide some sort of a justification of why the solution makes sense, just in terms of the mathematics of the situation? Lastly, what I want you to do is write a brief report. Now, a brief account of the whole process. So what was the question that you're seeking to answer? What are the variables you use? What analysis or analyses did you carry out? How is the analysis interpreted? Is the solution valid in your opinion? And what is the answer to the question in the end of the whole process? So that is, in a nutshell, what I'm asking you to do. There is a standard here that I would encourage you to read because I really want to see that you can apply the theory of linear functions to a real-world setting to understand improve understanding or decision making. So I'm really looking for you to apply linear functions in this particular modeling setting. And I would encourage you to, in particular, read what the four beyond proficient description is so that you can be sure and shoot for those types of, I guess, demonstration of those skills. Okay, so that is what you have there in terms of the Project 3 linear modeling. I did want to let you know that I have copied off the pieces of the Common Core so that include modeling statements. So here is the standards for mathematical practice in the Common Core. So these are processes or proficiencies that you should encourage in your students according to the Common Core. And the one that includes modeling is actually it's number 4, so it's on the second page. And model with mathematics is something that might be worth reading before engaging in the process so that you can really understand what it means to model with mathematics. Also included in this Project 3 resources is the practice standard, sorry, the high school standard for modeling, which is, I think, a kind of a better description than the practice standards give. So here we get a 2-page document that talks about, well, what is it? Here you can see that it's the process of choosing and using appropriate mathematics and statistics to analyze real-world situations, understand them better, and improve decisions. There's some examples of how that might look in a high school class. And there is, of course, the modeling flow chart that I showed you. There's also, of course, these steps, I guess, that I'm asking you to use as sort of a framework for your modeling report, or the requirements in the modeling, and just a little closure here as well. So also a good document to read just to make sure you understand what modeling is, what you're engaging in. What else to tell you here? There are some other resources. There's some interesting links. So I just did a quick web search on some, I guess, some topics that sort of, I guess are related to our project. So, here's the SodaStream USA main website. Here's where on Amazon you could buy a SodaStream maker. There's some Albertsons, I guess, coupons for last week, which might include soda water, might not. There's also an Instacart, Albertsons shopping mart, yeah, shopping site where you can buy sparkling water online and compare prices. There's also a LaCroix buy online, so you can actually buy direct from LaCroix if you'd like. There's also some interesting, the last few are some interesting things I found on the web, some commentaries about, SodaStream, is it worth it? Should I buy a SodaStream to save money? So some nice essays here by people who've investigated something really similar to what I expect you to investigate. So that's the Project 3 interesting links if you want to, investigate a few of those before diving in. And then the last thing I guess that's up there is there is a one thing that people who shop at Bed Bath & Beyond know about, that this store regularly sends you flyers, coupons that you can use to get 20% off a single item. So this might be one way that you could get a SodaStream for cheaper than list price. So you might want to incorporate that, in your modeling activity, so that it's as real as possible, that it really models the real world and the availability of resources, which include coupons in this case. Okay, well, so that's everything in the Project 3 resource folder. The modeling activity is due, when is that thing due? It is due April 13th, which is the second Friday after spring break, so it would be a nice thing for you to get a start on and think about. I will say that it does depend on you having a firm understanding of linear functions, which is, of course, a topic that we'll cover on Monday after break. But there's no reason you couldn't get a jump start by looking at that section 9.8, I believe it is, and seeing if you can apply some of the theory there to this particular setting. Okay, I look forward to your questions and a discussion of the modeling project when I return. Hope you all have a nice restful break, and I'll see you on Monday after spring break.